27 and 28 from the homework that we want to go over. Any other problems? Cannot combine. There were several, both 12 and 14. I don't think they either had the same index or what was underneath the radical was the same. So you weren't able to combine those any further. 24 as well? Sure. All right. So it looks to me like we have 24, 28, and 30. So let's start with those, okay? Let's start with 24. Okay. Problem number 24, we have here this problem. We have 2 plus the square root of 7 times 1 plus 3 radical 7. Okay. Now, something that we're going to kind of talk a little bit more about in the beginning of class today is the idea of a conjugate. Who remembers what a conjugate is? Anybody? We did it a long time ago. I'm not sure if you remember the word or not. But it's where you have two binomials where the sign in between is different. These two are not conjugates of each other because, first of all, they have the same sign in the middle, and the numbers are different. But we are going to look at something where we have conjugates here in a few minutes. Thank you. Let me pause the recording. Okay, so what we're going to do here, first of all, these are two different binomials. Am I adding them, subtracting them, multiplying them, or dividing them? Okay, and I'm actually going to distribute because I'm multiplying them. I have a binomial times a binomial. The parentheses have nothing in between them, which indicates we are, in fact, multiplying. So I'm going to take 2 times 1, which is 2, and then 2 times 3 radical 7. How do I multiply 2 times 3 radical 7? The 3 and the 2 only. Good. So that's going to be, and we have to add them because we have a plus sign here. That's going to be 6 radical 7.
I got a quick question.
Yes.
So when you multiply the number in front of 2, but when you add the number in front of 1?
I don't think I understand your question.
Like when you know how when you add 2 radicals, there's like no number in front?
If there's no number in front, then yes, it's a 1. Assume to be a 1 there.
And then when you multiply, there's no number in front?
When you multiply, there's no number. So this is just this 2. There is a number there.
Oh.
You're thinking about the index.
Yeah.
That's a 2. Yes. All right, so now we're going to go ahead. I'm going to change color so you can see the different thing that I'm using. The square root of 7 times 1 is just the square root of 7. And the square root of 7 times 3 square roots of 7. Well, I multiply the numbers in front, so 1 times 3 is 3. And radical 7 times radical 7 is radical 49. So when I multiply radicals, I multiply both the numbers in front and the numbers underneath. Now, we need to simplify this a little bit further. So I can combine these two things. Why is that? I know I can. Why? The same radical, and the indexes are the same. So when I add those, now I'm adding this time, not multiplying. When I add them, what am I going to be looking for? Or what do I add? Do I add the 7s, the 6s, the 2s? What am I adding? Only the numbers in the front. We treat them like terms. So this is where Chris was saying this is like a 1 in the front of the radical. So 6 plus 1 is 7. So I have 7 radical 7. That's what that combines to be. Now I have to look at the other two parts that are not highlighted and see if I can combine those, which I actually can. What is the square root of 49? What's 7 times 3? So this is actually 21. Now can't I combine the 2 and the 21? So my final answer becomes 23 plus 7 radical 7. Yep. Because this is 7. The square root of 49 is 7. 7 times 3 is 21. If you have a radical that you can reduce, you need to do that. Let's look at 28. 28 should have been very similar. I want you, if you did not get problem 28, because a lot of you got 6s since that's the one I graded, it's very, very similar, but what is different in the start of this problem? I have 2 radical 5 plus 3 radical 2 quantity squared. So what's different? The quantity squared is on the outside, true. Does that mean that I'm going to take this 2 and kind of distribute the power?
No.
Absolutely not. I never, ever, 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 ever distribute the 2 across the plus sign. Okay? Can't do that. Can't distribute an exponent like that. So what we're actually going to do is we're going to rewrite this. How? Multiplied by itself. I'm going to rewrite that expression 2 radical 5 plus 3 radical 2 times itself. I write it twice. That's where the exponent comes into play. 2 times. And then it should look like the problem we just did, right? So I want you to try it. If you got it wrong, I want you to go back and look at the same type of problem we just did and go ahead and do your distributing. Simplify everything that you can. I know quite a few of you got 6s on this problem, but quite a few of you didn't. Okay, so I want you to retry this one. And some people can do it right at the beginning, but some people can't. I mean, you just have to, it doesn't matter how long it takes you to get there, we'll still get there. So 2 radical 5 times 2 radical 5. Remember, I multiplied both the numbers in the front of the radical and the numbers underneath when I am multiplying. So since I'm multiplying here, I'm going to get 4 radical 25, which is 20, because the square root of 25 is 5. 5 times 4 is 20. But we'll get there in a minute. I'm going to take 2 radical 5 and I'm going to multiply it by 3 radical 2. Again, I'm multiplying the numbers in front and the numbers underneath the radical. Good so far? Then I'm just going to go ahead and do the same thing with the second piece. 3 radical 2 is going to be 6 times radical 10 again. And then I have, excuse me, 9 radical 4. If you look at the middle terms, which are right here, can I add those, Matthew? Yes or no? Why can't I? But why can I add them? The square root of 10, and they both have the square root of 10. Perfect. So when I do that, I keep the square root of 10, and I simply add the number in the front. These two things I'm circling now can also be combined because this is just 20. What is 9 radical 4 going to be? 18. Good. Because the square root of 4 is 2. 2 times 9 is 18. And I can combine those, and your final answer is 38 plus 12 radical 10. And again, that's the one that I graded for extra credit. What, baby? Yeah, well, we're not going to do 30 right now because I'm going to do 30. I think someone asked to do 30. I'll have to look. I'll see which one. Maybe it was 30. Or was it? Okay. Just give me a minute. Any questions on this one? We're good? All right, so Shami, I think you're right. I think I did say I would do 30. So I'll do that one, okay? All right, let's look at it now. All right, the last one from the homework that we're going to look at is 30. And here I have something a little bit different. And if you notice the directions on this one, it says multiply each pair of conjugates. And that conjugate is the word I just mentioned a few minutes ago. So I want you to look at these and tell me why they are conjugates, because they are. Signs are opposite, and only the middle sign, by the way, only the middle sign, and all the numbers are the same, right? That's right. Here's a key fact. When I multiply by... I don't think so. Oh, you're right. I'm sorry. I did write the wrong problem. I wrote 31. He's right. They're still conjugates, though. Let me write 30. If I had them, I need to go get some more of those. But I'm plumb out. I need to go get some. Does this look better?
You need a kickstart. Did you see the commercial yesterday for the Google kickstart?
No. All the Super Bowl commercials yesterday they made me cry. It's like, what the heck? They're all sad commercials. All right, looking at number 30. Are these conjugates as well? Because the numbers in between I'm sorry, the signs in the middle signs are different. One's positive, one's negative, and all the numbers are the same. Here is the key fact about conjugates. When you multiply them, the radicals go completely away. So your answer should just be an integer. It should be the number 4, the number -3, the number 2. The radicals are going to go away, which is why conjugates are important. Because remember, when we divide radicals, we don't want radicals in the bottom, right? So we use the idea of a conjugate to get rid of the radical, and we're going to do that in a minute. But let's go ahead and look at 30. I'm going to distribute the 4 and the 4, and that gives me 16. 4 times a positive 2 radical 3 gives me 8 radical 3. When I distribute the second piece, I have negative 2 radical 3 times 4, or negative 8 radical 3. They will, that's where the radicals go away. Negative 2 radical 3 times positive 2 radical 3 is negative 4 radical 9. And a show me saw right away, those two middle terms do what? I can combine them because they're both radical 3s, and when I add the numbers in the front, what happens? They cancel each other out. We get 0 radical 3. So now I'm looking at just these two. What is 4 radical 9?
So that's 3 times 4 is
12. Because radical 9 is 3. 3 times 4 is 12. So this becomes 16 minus 12. The answer is simply just 4. And I knew that when I multiplied by the conjugates, my answer should have 0 radicals in them. It should just be an integer. Okay? Friday was your last day. Okay, I'm going to have to do that in just a second. Okay? All right. Any questions about that? You had to wear your Patriot shirt. Nice. Okay. No, trust me, he has had it for a long time. All right, so I want you guys to look at this problem. Go ahead and put your homework away. Go ahead and take your notes out. And let's look at this idea here at this particular problem. First of all, what is the issue with the problem that you see in front of you? And why do I have a need? I need to simplify it. Why? There's something in a certain position that shouldn't be there. The negative really has nothing to do with it, believe it or not. You can, well, and radical 2. Where can I not have radicals to have a simplified answer? In the denominator. So if I have a fraction, I really don't want any radicals in the denominator for it to be simplified. So what did I just say? What can I do to get rid of the radicals? What can I multiply by?
Conjugate.
Multiply by the conjugate. And that's what we have to do here. If you notice, I have a binomial in the denominator. The problem that we did last class looked like this when I had radicals in the bottom. It said something like 4x over square root of 2y. Remember that? And we had to multiply by a number on the top and the bottom to get rid of the radical. Didn't we do that last time? What's different about this problem?
No variables.
Well, the variables, that's right, true. But there's also a plus and a minus sign down there, okay? And that means it's a binomial. So we really have to worry about conjugates here. And the conjugate here is going to be what? Nope. Only the middle sign changes. So it's going to be square root of 5 plus the square root of 2. And whatever I multiply by the numerator, I'm also going to multiply by the denominator. I'm not going to cross multiply. I only cross multiply when there's an equal sign in the middle. When I multiply fractions, I actually multiply straight across. Well, when I multiply across the bottom, I should no longer have radicals. Okay? So let's try this problem. You're going to have to do a little bit of work. So you might have to do a little bit of work off to the side here. I need to distribute, just like I did for homework, and I have to multiply these two things. So take a second while I pause the recording. Go ahead and distribute, multiply those. I'm starting with the denominator here, and worry about the numerator in a second. But tell me what you get. What happens when I multiply those two things?
In green is the bottom?
Yep, just the bottom across. Do you agree? Just doing some side work. But I agree, this is kind of the calculator in this case could be a shortcut because we are dealing with radicals. We know that the radicals are going to go away. And so I could simply just plug this straight into the calculator. I'm going to the eye doctor on Wednesday, y'all. I'm gonna get new specs. I can't see nothing. That's what I already have. All right. Radical 3. Not radical 3. The answer is 3. But we could distribute and simplify and get that to be the same thing. So the denominator here is simply 3. How do I multiply the numerator? Well, I have to use a keyword. I don't FOIL because I don't have two binomials. I just distribute. So 3 radical 2 times a quantity. I have a plus sign here. I have the square root of 5 and the square root of 2. That tells me I need to distribute this to both pieces, that plus sign. What is 3 radical 2 times radical 5?
So that's 3 times 1 radical.
3 radical 10. Okay? Plus 3 radical 2 times radical 2. 3 radical 4, but we can simplify that. That's just 6 because the square root of 4 is 2. 2 times 3, okay. Well, before I even simplify, what do you notice? Remember this?
No, I do not.
We did it with quadratic formula. When you have a denominator and a plus and a denominator that is just a monomial, a constant down there, and in the numerator you have a binomial, that number needs to go into both pieces, and it's the number in front of the radical. So in this case, we all simplify. So I just have the square root of 10 plus the square root of 4. Well, that's just the square root of 10 plus 2. That's my answer. Where did the 3 in the bottom go? What did it become? A 1. You could put it over 1 if you wanted to, but not necessary. Okay. Sure. It didn't turn into 1. I am choosing what I'm going to multiply here. Okay, that's going to be different every time. Okay, just like I was choosing it last class. Remember, what would make the radical go away in the denominator? When you have a binomial, which means it's connected by 2, and you have a radical there, you're going to choose those exact same numbers with a different sign. You're going to choose the conjugate. Because anything over itself is 1. When I multiply by 1, nothing changes. I'm going to give you one more to try, okay? I'd like for you to try one on your own. So, you guys try this one. This one's going to be a little bit harder, not too bad. So let's try 4 plus the square root of 6 over square root of 2 plus the square root of 3. I'd like for you to simplify that. Okay? Again, what is the issue with this? Why do I need to simplify it?
Because
Travis, why do I need to simplify this? What's the problem with it? Not too big. What's in the denominator that should not be there? The radicals. So I know I need to get rid of it. So I'm going to choose to multiply by something specific. I want you to try it. So I agree with this so far. And Oshome's right because I know that the denominator should multiply and give me no radicals left. I can put the denominators with parentheses around each of them right in the calculator, and it should give me a simplified answer. So you should very easily find the denominator. So the denominator, I agree, is pretty simple. But the numerator does not simplify on the calculator. They're not conjugates. You're going to need to do the work on your own. You are going to actually need to FOIL and multiply the numerators here. So you're going to need to do that side work. Distribute 4 times 2, and 4 times radical 2, and 4 times radical 3. When I multiply these across, I get 4 radical 2 minus 4 radical 3 plus radical 12 minus radical 18.
so
Right. And can I combine any of those things right now? No. Nothing under the radical is the same. But what can I do with these two things? Simplify them. The square root of 12, I can make a factor tree. I can actually simplify the square root of 12. What is the square root of 12? Yep, it is 2. The 2 comes out. The 3 stays underneath. So this becomes 2 radical 3. How about 18? How does it simplify? So I have 9 times 2. A 3 comes out, and a 2 stays underneath. That becomes 3 radical 2. Now you should notice some things at this point. You should see that this and this can be combined, and the ones with the radical 3s can also be combined. So my final answer on this problem is radical 2 minus 2 radical 3. That'd be 1 radical 2. And I have that all over negative 1. Not yet. The OPQ you're going to have in this unit is on solving radical equations. Here is another way to write your answer. I could also take this and say it is negative square roots of 2 plus 2 radical 3. And that's probably the most correct way to write your answer. Where'd that come from?
Because they're negative 1.
The negative goes into both of the pieces in the top and changes its signs. Can I do what, baby? How'd I get what, honey? From here to here? Okay, so these both have radical 2, so I can combine them. What is 4 minus 3? 1. So 1 radical 2. Then these two, negative 4 radical 3 and 2 radical 3. They're both radical 3, so I can combine them. Negative 4 plus 2 is negative 2. Okay? It's just, I mean, we're kind of like putting a bunch of stuff together here. Do you agree? We're remembering, how do I simplify the radicals? How do I know when I'm multiplying? When am I adding? When can I add? Bradford, why are you on your phone? Why don't you just put it totally away from me, dear? I don't want to see it. Thanks. Okay. That's about as tough of a conjugate problem as you would see. Okay? It's a pretty tough one, actually. Now, for today, we're going to do a little bit of review in the beginning, because this is all stuff you guys did back in pre-algebra, so you don't need to write this down, but I just want to review some stuff with you real quick. Okay? Properties of exponents. We're going to take exponential properties, exponent properties, and we're going to combine them with radical properties, because actually exponents and radicals are related, believe it or not, and we're going to talk about that today. But let's take a little bit of a review of properties of exponents. When I have the bases the same, what do I do with the exponents? Do you remember?
You add them.
When I have x squared, or x to the 5th over x squared, what do I do with those exponents?
Multiply it.
No, I subtract them. Okay, so this is going to be x to the 3rd, 5 minus 2. So you subtract your exponents. That's why we're reviewing, because nobody remembers. Okay, you subtract the exponents. When I have a power on the outside, and there's not a plus or a minus, I can go ahead and raise both of these to that power. Power of a power, I multiply them. When I multiply, what do I do with these? I add the exponents. Do you remember all these rules? Okay. We're going to practice and remind ourselves some of these rules. So I've got 3 for us to practice, and I have a whole bunch that you guys are going to do and turn in for a grade today. Okay? As a review, do we remember all this stuff? These are ones like you saw back in pre-algebra even, I think, and Algebra 1, and we did them at the beginning of the year. So I know this is at least the 4th time you've seen it. Probably did them in AFDA too if you took that course. So let's start with the one on the left. So let's start with A. I don't see any addition signs, any subtraction signs. I see a negative. I see some exponents. And the parentheses indicate that I'm going to multiply these things together. So what am I going to multiply? The 3, the -4, the -3, the 5. What am I multiplying? The 5 and the -3, the coefficients. What is 5 times -3?
15.
-15. And then because these are both A's, what do I do with those exponents?
You multiply them.
Nope.
Yeah.
I add them. 3 minus 4 is -1. We typically don't like there to be negative exponents, so where can I put that to make it a positive exponent? I can put it in the denominator of my fraction and make it a positive exponent. Final answer. I multiplied the numbers in the front, 5 times -3. I added the powers because they both had the same base as A. Because I can't have a negative exponent, I put it in the denominator of my fraction. You never learned that. I know. I just emailed the person that would help with us with that because do you mind if I turn the fan on and blow it around the room? Would that be okay? All right. I wasn't sure if y'all would want that, but I'm dying. So I guess you guys are too. Well, actually, since I brought this fan from my own home, my own personal home for the room, I wasn't really being selfish. I was actually being kind, right? So you're welcome, Travis. All right, let's go ahead and look at part B. This one looks a little different. What is that 2 on the outside here?
An exponent.
Okay. And it looks a little different than the first problem. Do you agree? All right, so yes. What is, I'm going to square the coefficient. What is -4 squared? Is it -16 or is it positive 16? It is positive 16. I emailed Ted. It's ridiculous. How do when I type in, so double check on your calculator, guys. What I'm about to type in is incorrect. What I'm about to type in is wrong. So look up here. -4 squared. What is wrong with what I just typed in? I need parentheses. Excellent. You're squaring all of the -4. -4 squared is positive 16. So I have 16. Now, I have x and I have a y. Each have a power.
What if you get the same answer in that first?
No. -4 squared is -16. Got to have the parentheses. You're squaring the negative as well. What power is my x? What do I do with that -3 and the 2? Multiply them. Here's where I multiply. What -3 times 2 is? -6. What's my power of y? Good. I cannot leave this way because I have a negative exponent. Got to get rid of that negative exponent. So where does it move? So I have 16 y to the 10th over x to the 6th. Final answer. Looking vaguely familiar, I hope? We did it earlier this year, so I know you've at least seen it once. How about letter C? Well, I have a 4 in the numerator as a coefficient. Do I have any number in the denominator like that? It's a 1, but nothing I can use to simplify it. So the 4 is going to stay in the numerator. If there was like a 2 down here, I would be able to divide those numbers. But there's not a number there, so I'm just going to leave the 4. How about the A's? Well, they don't all the way cancel because I have 5 in the bottom and only 1 in the top. So 1 minus 5 is -4, so I'm going to put a to the 4th down here. I have 4 more in the denominator than I do in the numerator.
Did you say subtract exponent?
What is 1 minus 5? I'm doing A's. I have 4 more in the denominator than I do in the numerator, correct? How about the B's? 5 where? In my numerator. Very good. So I have b to the 5th up here. And then what happens to the C's? There's no more C's, so I'm done. Okay? Right. Wherever the bigger number is where it goes.
Wait, the B's canceled out too? Oh, no, never mind.
There's five more on the top, right? All right, so I have some problems here for you guys to work on. I only want you to do the even problems, 2 through 18, okay? 18 looks a little crazy, but I want you to look at it for a minute before I set you on your way. If you look at 18, there are a lot of steps. I'm going to try to print this out for some of you as well. Okay, I think it might be good if I printed these out, like so you guys have them in front, because I think this is a little hard to see down here, especially for those of you in the back. So I'll do that. But can you just kind of look for me for a minute before I set you free? These negative exponents, do you see them right here? You're going to need to move those around. But we have a negative exponent out here. So why don't we do our multiplication first and then move everything around? Does that make sense? So you're going to multiply this -1 times this -1. You're also going to multiply the 2 times -1. -3 times -1. So you're going to end up with some negative exponents. That's okay. You know where to move those. Okay? All right. So let me do some printing, and you guys can work on these, okay? Again, guys, these even problems are due before you leave today. You are going to have a separate homework assignment, and I'll put that up on the board. All right, guys, your homework's written on the board, and it is out of your textbook. It is separate from your classwork assignment. The homework is a mixture of review problems from everything we've done so far with radicals. So it's a nice review. You will have a quiz next class on everything we've done with radicals up to this point. So this right here that you see, this homework assignment, is a quiz review. So make sure you're aware of that.